Let's take a look at today's lesson. Today's lesson is on derivatives and tangent lines of trig functions. So this probably is the first time that we've talked about derivatives, or one of the first times. The derivative is something we would deal with in calculus quite a bit. If you're in physics, you're probably familiar with velocity. Velocity is the first derivative of the position function, so you probably have some knowledge about derivatives. Today what we're going to do is we're going to look at a derivative as the vehicle that gives us the slope of the tangent line. There are a lot of uses of the derivative. Today we're simply going to focus on the fact that the derivative gives us the slope of a tangent line. You probably first experienced tangent lines perhaps in geometry. You probably, drew lines tangent to circles, because that's a big thing with geometry, right? So you know what a tangent line is. What we do in calculus is we take that concept and we generalize it to any function. It doesn't have to be a circle or a geometric figure. You can draw a tangent line to all kinds of different functions and curves. So this is an example of a tangent line being drawn to this curve. Okay, and so our purpose today is to write the equation of a tangent line and use it to approximate something. So let's talk about that. So to find the tangent line, or what we would use, my favorite equation of the line, right? Yes, I have a favorite equation, y minus y1 equals m times x minus x1. Great equation of a line. So that's the line that we're going to use to write our tangent lines today. So the steps to do that, I've written those out. So first we would determine the point at which the tangent line touches the graph. That's not really something that we typically have to find. They usually give that to us. In this particular case, we would just need the coordinates of this point, whatever that point is. So that's first, we need the coordinates of that point. Then secondly, we would find m, which of course is the slope. We would do that by finding the value of the derivative at that point, at the point of tangency. This is called the point of tangency. Thirdly, we would substitute those numbers into our lovely formula, y minus y1 equals m times x minus x1, and then we have a tangent line. That's what we're going to be working on today. Once we get a tangent line, we're going to learn how to use it to approximate values of the function. So this is called linear approximation. It's a concept that for some reason students have a difficult time with in calculus. I think it's a pretty straightforward concept. We find the equation of a tangent line and we use it to approximate stuff. And it's really all we're going to do. But I want to start us thinking about it right now in Pecal. How does that work? So that's called linear approximation. So basically what we would be doing is we would use this tangent line to approximate. So let's say, for instance, we wanted to approximate this value, that y value on the function. We would just use this tangent line and find this y value, and that we would use it as the approximation. I mean, that's really all that we're doing. As you can see with this tangent line, the farther I move away, the worse my approximation would be. Right? If I tried to use this to approximate this, this really would not be that good of an approximation, right? So the closer we are, the better we are. So that's the concept that we'll be working on. We're going to be using our calculators quite a bit, and I'm going to be going through some calculator strategies with you. So hopefully you have that ready to go. So let's go ahead and go to our example. We have one example today that I'm going to go over in quite a bit of detail. So if you would go ahead, and if you need to write this down, because what I'm going to do is I'm going to shrink this to half of the screen so I can pull up my calculator for the other half, so that we can do, go back and forth. We can look at the calculator and this each time. This is the equation we're going to be working with today, 3 sine 4x plus 2. That's the equation we'll be working with. Okay, so we have our problem here. We have our calculator. What I would like for you to do is to go to y equals, and I would like for you to enter y equals 3 sine 4x plus 2. Just go ahead and enter that right here in y equals. So we have 3 sine 4x and then plus 2. Okay, so we have that all entered into there. Make sure that you're in radian mode, because this isn't going to work very well if you are in degree mode. So please be sure you're in radian mode. We would just go over here to mode and check. So I'm in radian mode, so we're good. So we do this in calculus a lot. We we want to input the equation one time instead of multiple times, so we put it here in y equals to just kind of rest right there, and we'll work with it. I'll show you how to work with it. So what we're going to do, we're going to find the tangent line. So let's go ahead and write down, it's right over here, the things that we need. So we need y minus y1 equals m times x minus x1. Those are the things that we need. I have my x1 already. It's kind of off here. It says x equals 1. So I'm going to go ahead and put that in. I need to find my m and my y. Since we're going to be using this to approximate a value, what I would like to do is to go ahead and solve for y. So y equals y1 plus m times x minus x1. Hopefully that isn't too troubling to you. I'm simply moving the y1 over because my purpose, I have a purpose for finding this. I'm going to use it to approximate. Alright, so now we have this first value. We need to find our y1 and our m. So let's talk about how we do that. So we have the x value of the function that we want to use, but we don't have the y value. What I will encourage you to do is to go to a blank, well, what we're going to do is we're going to use our calc screen, this here, second calc, and value. I encourage you to do it this way. Yes, there are other ways, but I'm going to show you why this is going to be very helpful. Alright, so we're going to find the value. And well, I want the value at 1, right? That's what I want. I want the value at 1. So you would type a 1 in here and hit enter. So type a 1 in and hit enter. See our y value pops up right here? Now the great thing about this, doing it this way, is right now our calculator has this value stored in y, in alpha y. It's where it is. And I really want to store this. I want to pull it out of there and I want to store it. So let me show you what you would do. So we're going to go to a blank screen, second quit, and I'm going to see the y that's right down here above the 1 key. We're going to hit alpha 1. That gives us a y, and hit enter. And you'll see that that value that we just calculated is there. That's why we never ever store under x or y, because the calculator stores there. It stores there every time you do something in the grapher and you find an x and y, it stores it there. So we don't want to do that. So we're going to take this and let's store it as a. So we hit the STO button. We're going to store this as alpha a. Okay? And so it's stored there for us. So let's go ahead and fill in our part over here. So we have y equals, and we turn our y1 is negative 0.2704. Okay? So that's our y1. We have it stored as a. I'm going to show you why we're doing that in just a moment. It's really going to help us because who wants to type in all of these digits? I mean, what if I make a mistake and type 1 in wrong? All right, so it's stored in the calculator. We don't have to touch it again. All right, so what are we missing? We're missing our m, our slope. That's what we're missing right now. So we're going to let the calculator do it for us. So the button that we use to get to our derivative in our calculator is math 8. So type print in. So we want to, the math button's right here. So math 8. If you have the new operating system, it should come up and look like this. If you don't have the new operating system, you should really get it. Talk to me if you don't have it. We'll talk about it because it is very helpful for you for this year and for next year to have that new operating system. So it's dx. We would put an x here. Now I want to put my function there. I've already typed it in one time. I don't want to take a chance on typing it in wrong. That's why I do it once correctly. So the way that I get my function to appear here is to do alpha trace. See, if you do alpha trace, see all these y's that come up, give you lots of options. Our function is stored in y1, so I'm going to choose y1 and hit enter here. So now I have the derivative at y1. And what was the x value that we wanted to know the derivative of? It was 1, wasn't it? So I'm going to put a 1 in here. And then I'm just going to hit enter, and the calculator is going to do all the work for us. Now next year you'll be able to do this by hand. We're not going to worry about that this year, right? I mean, we're just going to be using our calculator to do these things. So let's go ahead and put that in our formula over here. So our slope is, what is it, negative 7.844. Okay. I'm going to, so we stored this as A. I'm going to store this as B. Basically for our benefit. So I go over here, I hit the store button. I'm going to store that as alpha B. Okay, so there is my number, because I don't want to retype it over and over again. Alright, so now we have our tangent line. That's fantastic. That's our first goal, is to get our tangent line. It's written right here. We will now want to use it to approximate y of 1.2. So what does that mean? What do we want to do? We basically want to, so y of 1.2 is approximately, right? What we want to do is we want to put a 1.2 right here where the x is. That's what we're using our tangent line for, as an approximator. We're going to enter the 1.2 right here. Okay, so y1 of 1.2 is approximately negative 0.2704 minus 7.844 times 1.2 minus 1. Okay, so that's what we have. Just this calculation that we need to do. So let me show you what I'm going to put in my in the grapher. So this was A. I'm going to type in A plus B. Why am I typing in a B? What was our B? It was negative, right? So I'm just going to say A plus B, and I'm going to multiply B times, what's 1.2 minus 1? 0.2. That's all I'm going to type in my calculator to get my answer. A plus B times 0.2. So let's go over here to our calculator and do that. So alpha A, so plus A plus B times 0.2. And that's our approximation. So y of 1.2 is approximately negative 1.839. So we have our tangent line right here. We have our approximation right here. Okay, so what I would like to do is I would like to graph this tangent line and our original line and just kind of show you what we found. I mean, let's just look at it, see what it is. What are we doing? So let's go to our calculator, to the y equals. So I have my function in there already, right? I want to write my tangent line here. I just want you to see what it is that we found. Our tangent line is this, y equals A, so alpha A, plus B, and then times x minus 1, right? Then times x minus 1. So let's look at the graph of these and let's just see what's going on. What did I find? So the blue is the curve that we, the 3 sine 4x plus 2. And see the red line right there? That's the tangent line that we just found. You see that? We found the tangent line at 1. See how that point of tangency is at 1? We calculated the slope and we found the tangent line at 1. That's what we did. And we just used this tangent line to approximate 1.2. So so this is 1 and this is 2. So 1.2 is probably, it's really close, right? Maybe in here. I don't know. So we basically used this value to approximate that value. So it's a fairly good estimate. Maybe not perfect, but it's pretty good. That's what we just did. Okay, does that make sense? All right.